In this example, the cost of producing X unit of a product is given in dollars by the cost function Cx equals 250 plus 45x minus 0.2x squared, where x is greater than or equal to 0. We're going to show that the average cost function is always decreasing. And that means for this situation, in which increased production distribute the cost so that the cost per unit decreases. So first of all, we're going to identify what is the average cost function. We call the average cost function. I'm going to use the notation AC as the C bar of the X, and to compute it by dividing the cost function by X. The cost function is 250 plus 45 X minus 0.2 X squared. So we divide all of this by X. To show this average cost function is always decreasing, that means we're gonna show the derivative of the average cost function is always negative or always less than 0 for x is greater than or equal 0. We're going to work on finding the derivative of the average cost function. First of all, since the AC is in the rational form and divided by x, the restriction of the rational function is the denominator cannot be 0. That means x cannot be 0 or the domain will not include the point x equals 0. From this, we're going to keep going with finding the derivative. I will use the quotient rule because I see this as a quotient form. All right, so identify the numerator as a high function and the denominator as the low function. To find the derivative using the quotient rule, so the AC prime, using the quotient rule is low d high minus high d low, draw the line low squared. And on my prep notes here on the side, I'm gonna work on identify my high is 250 plus 45x minus 0.2 x squared, and my lower function is x. Find high, d high to get the derivative 0 for the derivative of 250, 45 for the derivative of 45x minus 0.4x for the derivative of the last term, and the d low or L prime gonna be 1. Write h prime in the nicer form, which is 45 minus 0.4x. My prep work's ready. Now I'm gonna bring it into the main part of the problem. So the low, which is the x, multiplied by d high, which is 45 minus 0.4x, subtracted by the high, which is the quantity 250 plus 45x minus 0.2x squared, and multiplied by d low, which is 1, all divided by the low squared, which is the x squared. Next part, I'm going to simplify the numerator by distributing x into the parentheses for the first group and distribute the negative sign to all terms for the second group. I have 45x minus 0.4 x squared minus 250 minus 45x plus 0.2 x squared, and all divided by x squared. As I see, 45x minus 45x can be cancelled, and then negative 0.4 x squared plus 0.2 squared becomes negative 0.2 x squared, and then subtracted by the number 250, all divided by x squared as the simplified form of the derivative of the average cost function. Next, I'm going to identify what interval that the average cost function is decreasing, or to verify it's going to be decreasing everywhere, right? Now, to determine the critical number, I put a note to myself. To find my critical number, I'm going to need to consider two cases. the case that the derivative of the average cost function is zero, and the case that the average cost function is undefined. When I have the average cost function derivative in the fraction form, I will name the top as the numerator, the bottom as the denominator. To consider the case that the average cost function derivative is zero, I'm gonna let the numerator equal zero. And the case that the derivative of the average cost function is undefined, this case, I'm gonna let the denominator to be zero. For the first case, the numerator is zero. It's negative 0.2 x squared minus 250. Let it be zero, and then solve for x at 250 both sides divided by negative 0.2. For the x squared, if you divide 250 by 0.2 with a negative sign, you have negative 1250, which is not possible. Why is not possible? Because if you take the square root, you cannot take the square root of negative 1250. Or the other way, you cannot find any number that multiply itself and then return the negative sign. So no such critical number from the case that the derivative is zero. And then for the second case, the derivative of the average cost function is undefined by setting the denominator to be zero. So we solve for x. It's very nice and clear. We have x equals zero, but in fact, the x is zero is not one of the domain, or the function is not defined at x equals zero. So then we just ignore this case. Okay, we can say that x equals zero is not in the domain, mean the domain of the average cost function, not the cost function. Because think about the applicable way, the practical way. The average cost is from dividing the total cost by x. The x has to be non-zero number, otherwise you have nothing to divide. So with these two cases, all right, we can just consider like the case starting from the zero or anything on the right side of the zero and the sign of the average cost function derivative. For the average cost function derivative, we have the term negative 0.2 x squared minus 250. The numerator always negative. Why is always negative? Because both terms, they have negative inside. And the x, we're gonna look at only the x is greater than zero, where the bottom or the denominator always positive. So when you divide the negative by positive, you're gonna get result as negative number. So then the sign of the derivative of the average cost function always negative for x greater than zero. We can make a conclusion at the end here as so for x greater than zero, the average cost function always decreases.